Guys, guys. You really need to know the difference between congruent and similar. Congruent means same shape, same size. It's like having Mrs. Landers and then a twin of Mrs. Landers, right? Or similarity would be like if I was Mrs. Landers and then I had like a daughter who's like the mini version of me, okay? Or maybe my mom and she's like way bigger than me, okay? So similarity means same shape, but different size. And so when you're doing transformations, most of the transformations we do are rigid, which means they're going to be congruent, like rigid. It's going to stay the same as much as possible. Similar is when we stretch or squeeze. And then they're just plain old straight up not congruent when they don't even have the same shape. Okay. So this one feels a little more complicated, but just imagine, okay, could I get from one shape to the next by doing transformations? Basically, if I flipped it, spun it, reflected it, would I get the same exact, like, is it the same exact shape? Okay, once I spun it or did anything other than stretching or shrinking it. Okay, and on this one, it is congruent because you can map. Which one are we going to? We're going from the one with J to the one with the C. So you can get this to this by doing like a reflection and a translation, it looks like. Okay, but you don't even have to tell that part. That's the hard part. Oh, I'm so sorry. I am not showing what I'm pointing at. Okay, this one is congruent because rigid motions can be used to get from this to this. Okay, on this one, it is similar because rigid motions and dilations can be used to map that as well. Okay, so they've got that written out. We've got that explained here. There's actually more of an explanation where they show you what I'm talking about. But basically, remember, if it can land, I mean, similar, similar things can be the same shape, but not necessarily the same size. Okay. And the scale factor is 1 because we land, like we get the same thing. Like it's like Mrs. Landers times 1 is Mrs. Landers, just the exact same size and shape. Okay. But it is, I will admit, it's a little bit of a funky way of dishing out this understanding to you guys. So on this one, guys, at first glance, like right off the bat, are they going to be congruent? Is there any way they can be congruent? Can they be the same shape? No, they cannot be the same shape. They're not even going to be similar. Similar is like closer, but like similar just means same shape, but different size. So there can be some differences with similarity, but no, this one's just not going to work. It's not going to be congruent because you cannot map those. This would never turn into that one. Okay. So that they say here, it is not congruent because rigid motions cannot be used. There's no hope. Oh my gosh, I'm pointing and not showing you again. I am so sorry. Okay. So not congruent because rigid motions, there's no hope. It cannot be used to make one into the other. Same thing with this one. Okay, they're not even similar, unfortunately. Sad day for transformations there, but it's true. So it just depends on the shapes that you get. And on these particular ones, that last one was never going to be congruent and it wasn't even going to be similar.